right. I think we're live again. Let's check that the streams are live. They seem to be. All right. Hello, everyone. It's been not as long as last big break, but yeah, we are live again. We will be doing some more work. It will be a shorter stream today because it's later now, and there will be dinner over here rather soon, but I decided that it would be nice to at least do a short stream, especially because there was a lot of discussion on Twitter and on in our chat, in the Gitter chat, regarding a bunch of design decisions on both actually on the FX2 grok as well as on the BitMagic. So I wanted to update you really quick. So on the FX2 grok, there was some, so I think Dr. Tune, he mentioned first that it would be nice to have the IF clock input output available, because the FX2 chip will be able then to arbitrarily clock data in and out of the chip, because usually you use an internal clock generator to use it as a logic analyzer. So you basically set it for 10 megahertz and then you read out the GPIOs in one go and you let the hardware basically push it through into USB. Having a separate clock input will allow to use high-speed data sources without getting issues with aliasing and being able to basically push the chip further in the bandwidth that it provides. I think that's the main reason. I think Micah also mentioned that she hacked some of the evaluation boards for the FX2 to get that pin out for certain of her projects. So after consideration, I think we will be adding that pin in a future revision of the FX2 grok board. The question was also, will we be adding this pin? So we have already a trigger input on the 7, so it's 14 pin connector that we currently have. So we will be, I was questioning if it would be useful to just connect that one pin, because it would pretty much replace a trigger pin. But I think it would be, so the concern was that it will capacitively load that the clock pin even further, making its usefulness, diminish its usefulness, because I hear that it is quite sensitive to the input clock like cleanness. So I think we will have to add it as a separate pin, which means we will have to change the connector again. And because of all that, I think we will also just change the pin header on that board so that there are several even spare not connected pins, just for future expansion if we decide that we have to bring out more signals or control signals, to be a little bit more future-proof. So if you have any additional input, please make sure to look for the schematic on GitHub. I think I posted it on Twitter too, the schematic, the current schematic. So if you have ideas why we should bring out any other pins from the FX2 onto the connector, let me know, because for the upcoming version that I already ordered from Oshpark, obviously that will not change. We might prototype and bodge a wire on just to test it out and play with it. It shouldn't be too much of a problem, because we can bodge wire it out with some magnet wire. So we can prototype this, and yeah, I might spend some time like do another stream just making those changes to the design, but I probably will not order another PCB until we have tested a bunch of stuff on the current one, just to not waste cycles on those PCBs, because we might find some issues with the board itself, and then the intermediate board that we order will be useless. Yeah, so that would be a little bit of an FX2 update. Now we will continue some more work on the BitMagic. And the BitMagic, I spent pretty much all yesterday just digging through documentation of the USB Type-C standard and what is available there and all the chips that are available there. And I came to the conclusion that the USB Type-C connector is not the right way to go here. It turns out that USB Type-C connector, so it doesn't buy us much, this guy, regarding functionality, besides being reversible and cool and interesting new technology. But the problem is that if we want to use it, we either have to make this whole board be a dongle, because if you do make it a dongle, you can tie the CC1 and CC2 pins to correct voltage levels and force the upstream. So upstream is host, downstream is client, but it changes depending on what you wire together, because you can take your phone and wire it to the device and vice versa. So the roles can change, meaning that we can force the host to do the mux, so switch the two TX1, RX1 as well as TX2 and RX2 differential pairs to be connected in the right order, because this connector supports the alternate modes where you use both differential pairs. Everything becomes much more complicated. And if you do make it a dongle, then you can force the mux to happen. The problem I can imagine being is if you and the problem is if we use a receptacle on the board side and we would be using a USB-C cable to a USB-C host, then we would be able to force that too and not use a mux either on our end. But yesterday I went out and I got some USB-C cables, which are, in my opinion, still ridiculously expensive. Like $23 for just a stupid USB-C cable is just crazy. But I did some measurements. So for example, this is connecting all the pins together, and so they are actually correctly connected. And regarding this other cable that I also got, it is a USB 3 to USB-C connector. And this one, I measured this through, and it turns out that there's no, it's only connected to one differential pair on the USB-C side to the USB 3 connection. If it was connected to both, probably we would be able to force it, or if it had a mux built in, which I would have expected for cable, for a technology that Apple was involved, because they love putting electronics into cables. So yeah, it's ridiculously complex, and if I want to connect the USB 3 with the USB-C connector, I need a mux on the device side. So at the end, it's becoming more and more complicated. We cannot get rid of the mux as a device, making things more expensive. I need to add probably additional power management chips like MOSFETs to switch power and stuff like that. So at the end, I asked in the chat what people think, and pretty much the consensus is we are removing the USB-C connector. Yeah, so I actually also found that in the standard library from KiCad we have the USB 3 connector, so we will be switching to the USB-B super speed connector, because all we need is the additional differential pairs for the USB 3.0, making things much simpler. We just need that connector. We don't need special muxes and stuff. So another thing that Micah actually mentioned in the chat, which was a good pointer, we should just wait for a few years until the USB Type-C stuff matures a bit. There's more silicon that supports this technology built in and a little bit worked out and with better prices. Because, for example, the integrated power control and mux chip that I was considering of using, the HD3SS322, it's a $2 chip itself in small quantities. It's like, are you serious? The 40 cents, maybe 30 cents. Okay, fine. I can consider that, but just adding a mux to be able to use a connector that is like a $2 chip, I don't think so. So yeah, we are ripping this out. I thought we will be able to have some fun with this, and it won't be. It was basically my youthful ignorance, thinking that we can just use the USB-C stuff and it will be fun. But it turns out it is quite painful and not technology we want to dive in unless we have to. For example, we want to have video output, or we want PCIe or something like that. Then yes, USB-C connector makes sense. Or we want power control, like drawing 3 amps at 5 volts into the device. Then USB-C connectors make sense. But otherwise, I don't think this is the right way to go. All right. Delete block. Come on. So let me mark this. Yeah, so this makes things easier. We have shield. Yeah, and we can ground this. I think I should just put it on the other side. That's the ground pin. Then we need VBus, and VBus will be basically connected to our 5 volt. Yeah, I deleted that stuff, but that's not a big deal. No, not field value. I don't want to copy the field value. Oh, I forgot to start the keyboard monitoring. No, it should still be running. Okay. Yeah, it was a little bit faster startup today. I didn't have as much run up as I usually do for getting the stream running, but it makes things a little bit easier. And I just wanted to quickly update people. Hey, Anonexus. I don't think we are breaking much today. We will be mostly doing some layout for another 45 minutes or so, and I just wanted to, at the beginning of the stream, talk about some design choices we will be making for FX2 Grok, as well as this system, and yeah, that's what we will be doing today. Yeah, so we want the power support. Yeah, I think I have it aligned. So the nice thing is I found out that the standard library from KiCad actually does have the super speed connectors, even including the connector I tried to use yesterday. So if you go as USB connectors, yeah, there is USB-C receptacle and USB-C plug, and there is USB OTG. I think that's what I'm using somewhere else. Then BA, and it has even nice indicators of what the rough footprint is. These are nice, nice footprints. I might copy it into my own library eventually, but for now we just want to move forward a bit and get some routing done. Yeah, and yeah, obviously this is pretty easy. We'll just connect this stuff directly to here. USB TX minus, USB TX plus. Yeah, it's not as nice as the USB-C connector, but this whole double and reversibility stuff where you need a mux, I'm still shaking my head. It's why are you making it so complicated? I'm disappointed that they all the super smart people working on this could not come up with a solution that is not requiring special custom silicon to make it happen. Yeah, so we will probably just connect all the data stuff to the FPGA. There is an interesting part that I hope to get some. I will have to check myself, but as far as I understand, we will have to connect the clock output, because the stuff is it needs to, so the clock is driven from the FT600 chip. So this is, even though it is the slave to the client and it is receiving data, it is dictating the clock to the device. So what we will do is use the FT600 that is generating the clock as the clock source for the FPGA. To do that, we will have to connect it to one of the GB in pins because they are global. This stands for global in. And global in are routed within the fabric of the FPGA so that it can be distributed better. So these are the good sources for clock inputs. So the order of the pins will be interesting because we have the data pins that are bidirectional from the FT601 connected to the GPIO banks, and then and then in the middle of it we need to connect the clock pin. But yeah, and then we will also do the more complicated stuff here, but let me just label this stuff here really quick, well, relatively quick. And how do we call it? Just from D0 to D31, maybe like that, yeah. Okay, so this would be clock. For the D1 and D0 pins, that will be our SDI and SCK pins. Because SDO, data out, I don't think we need the data out. We only need the first two pins connected here, and we can actually double label them. I think KiCad allows us to double label, and then we will label it D1, D0, and also maybe C for config, CSDI, and CSCK. Yeah, let's do that just temporarily. Maybe there's a better name. CSDI, no, SCK. Call it like that. And what we want to do is get the data stuff. So byte enable. So this is the interesting part here. If you get over USB data into the FIFO, or vice versa, you want to send data out, you can fill a full packet with 4 bytes at a time, so it is a full word, and you can use the byte enable pins to tell which parts of the 32-bit data word is currently active. And you usually just set the byte. If you are ending a packet, you basically if you have a 1xs byte, then you will only do byte enable 0 and leave the byte 1, 2, 3 below, so they are disabled. So the FDDI chip knows that there is only one byte still in this package. So it's an interesting solution for streaming the data out. But we will need to connect this to, and we will name it just the same, BE0, BE0, BE1, BE2, and BE3. Yeah, transmit empty, transmit buffer empty, and receive buffer full. So basically the buffer on the FTDI side, if it is full, this pin will go high, and this pin will go high if the receive, so when we, yeah, and the transmit buffer is empty, so we can shift data in, then this one will go high, or low in this case, because it's reverse logic. We probably need to move these a little bit, because they will collide with our labels. And the SIWU, as far as I remember, this was some reserved thing. Let me check the datasheet at some point, but let's not do that now. But I have to check that. The CWU thing, I don't think we needed that for what we are doing. Is this stream still working? Because Restream seems to be complaining that it is not connected to YouTube. Weird. Yeah, it seems to be fine. Yeah, I see the stream on YouTube. It's just Restream doesn't know anything about it. Okay. Okay, good. Hi, Dr. Toon. Welcome to the stream. You probably missed the very beginning of the stream. I was already talking about your proposed changes to the FX2 grok and how we will address that. And that will be a separate stream after we get some samples of the current setup that I had. So yeah, if you have any additional requests for hardware changes, they are welcome for the next redesign, and we will do that. But for now, we will just so we are working on the high-speed data pipe thing for now, at least in today's stream until dinner. So right, this should be a 3.3 volt thing, right? Yeah, because the I/O, we set everything, VCC I/O is at 3 volts. So we can copy this and pull this up. So we have to preload these with correct values when the FPGA is still not set up. And we will move these so that we can have connections here. Yeah, that would work. Yeah, maybe we do this like that. Okay, so TXE. Yeah, I'm almost tempted to give everything that the FTDI has, all the signals, give some prefix. But I don't think we will run into too much of a problem here. I think we should be fine with those signals, because I was thinking maybe we should prefix all the data with like F. This might be necessary if we also have an SRAM chip on the board to do additional buffering in the future. So we might need to add some prefixes here, or at least give the prefixes for the address and data lines for the SRAM chip. If we decide to add that in the future. And that will unlikely be part of the first design, because I want to keep it as simple as possible for now. Unless there's some very interesting technology thing we want to explore. I was really looking for like excuses to work on the USB-C stuff, but at the end it's just yeah, I continue talking about that. Yeah, but yeah, we decided to not do that because I could not come up with good enough reasons to stay with it. And so Anon Nexus is asking if I plan to add any storage for later examination. At the moment, no. It's just a streaming pipe, and this is meant. Well, there is always buffering. There is always storage. In the FPGA, there is some RAM block RAM that you will be using for buffering stuff between here and the USB interface, so that you can compensate for the packets not being picked up as fast as one, or not regularly. But the idea is to use it the same way you use the FX2 logic analyzers with Seagrok to stream the data to the PC. And then you have plenty of storage. Then you can store as much as your hard disk can hold of data. And then you can also decimate it the way you want with filters. But the interesting thing is, because we have the FPGA, we can do some data decimation and compression in the FPGA itself. So we will have plenty of opportunities of interesting stuff to be done on this design already. But yes, regarding really high-speed data acquisition, we might still exceed the USB super speeds at some point down the road, and then storing it locally in a small SRAM chip would be useful. The problem is normal, like easy to use SRAM chips are not fast enough. USB 3.0 is faster than most SRAM chips. So there is the hyper memory or something chips that are out there, which we would be using then, and we would not be using just normal SRAM chips, because this is basically DDR with a fancy interface, which is pretty nice for storing data, like block editing. But from my experience and what I hear, also Uwe Hermann from Seagrok, he also says the most useful thing is to be able to stream the data out. Yeah. And then you can analyze it on the fly, and then you can quickly turn around and see what's going on. Now the question is, yeah, I will have to look what the reset and wake up pins need, if we need them at all, or which circuitry they need. And then we need the GPIO. This will be C reset B, will be connected here. So the programming works by pulling the C reset pin, and then you can clock in the data and release the C reset pin, and you have the new bit stream loaded into the FPGA, which is quite nice. Yeah, we currently, with this setup, with the CS clock and CSDI being connected to the data pins, we don't need the second GPIO. If we had a third GPIO, then we would be able to do everything in one go and not need separate separate lines and abuse the data pins, as I explained in the last stream. Yeah, let's not do the GPIO for now. Let's just call it unconnected. We might want to put it on a pad or something for debugging purposes. And we will flip this guy. Yeah. And VCCIO, and this will be 3.3 volts. IO is at 3. And we will leave that at 3. And then we can just do 31 and make a gap for the clock. Yeah, because this is 144. We will have to, of course, see. Yeah, this is a thing I just saw on the IRC channel for KiCad. People were begging for a possibility of gate swapping for FPGA design. So yeah, I totally can understand that, where you want to reorganize the pinouts of the FPGA because yeah, you want to have the routing better and have the signals connected where you want, because you can change it in the HDL quite easily. So yeah, this would be a really nice feature to have. Yeah, for now we will just do it in the same order. Yeah, I am tempted to go for VCCIO that is lower voltage. I have to check where the cutoff is in speed, because there is a speed limitation. If I go too low in voltage, then in the datasheet, if you look at that, the ICE40 has a limit. It has to be high enough voltage so that the GPIO pins are fast enough. There is a limit to that. But yeah, this is something I have to check in the datasheet exactly where the voltage cutoff is. The other reason to not mess around too much with the voltage, it's like we definitely need 3.3 volts already, for sure, because that's what's required in the FTDI chip here. So we would have to add an additional voltage rail, and if there is not a really good reason to do that, like we otherwise don't get the bandwidth, for example, then I would rather stay with less different power rails. And this is weird. I did this wrong. There we go. That's better. So this would be clock. Let's do that so that I don't make a mistake. Just for now. We probably will want to change this kind of stuff. No, how? There we go. Right, so we have the clock input. Yeah, let's continue on these. Should be still usable as a normal GPIO here. What's going on? There we go. Yeah, so yeah, and on Nexus you're mentioning the blue line. It's only graphical. It has no functional, no function functionally. So I have to do what I'm doing now anyways, no matter what I do. I can't just draw a blue line and connect this stuff together and be done with it. It would be nice if it was the thing, but it's not. Yeah, yeah, the same way as Eagle. unfortunately. I wish it was more intelligent. We still might use the line for the graphical effect. Oop, that's a mistake. Yeah, this is how you make mistakes. Especially when you're a little bit tired. Yeah, I don't think we need more G-bins. The question I have, that's something I will have to check. We might need to have the clock connected to the G-bin of both banks that are using the data. Because how is this just a global distribution of the clock signal within that one bank? Or will it work for more than one? Yeah, in theory. So Alan Nexus is saying it seems silly that they can't use the pin name as a default name for a signal unless directly named by the user. Would make adding a big blue line easier for everyone involved. In theory, the problem is the names don't match here anyway, so I still have to connect the IoT 168 to a pin here. What Eagle does, if you could make connections, uses like internally fake names. Well, KiCad actually does too, if you just connect the wire together, like with the wires. Yeah, I don't know. It's it would have to be some kind of a system where you draw the blue line and then indicate from where to where and say what the counting direction is of the data signals, so that the software knows in which order to name the pins. So it's not that simple as just connecting one blue line and be done with it. It might create like a array of data, like with prefix of, you might have a tool that generates this to be able to say, it's like from here to here, create a bunch of labels that are from 0 to 31 with the prefix D. That might be the way to go. It's, I think, is there even a duplicate thing? Yeah, you can create an array here, right? Yeah, no, not in the schematic. In the PCB design, you can create arrays. Yeah, you could do that. And this is bank 0, which is good. 10, 9, 8, 7, 6. Oop. Okay, we are out of this bank. Now we need a second one. Orient component. There we go. Yeah, no, I agree that it is a useful feature to have, but someone would have to implement it, and I don't think this is anywhere near a high priority thing at the moment for the developers. Although the developers are implementing what they feel like is they are interested in working on one hand. So if one of the developers decides that it is interesting enough or high priority enough, then they might work on that. But we cannot force them to do this. All we can do is write a ticket on the bug tracker with a feature request and describe what we would love to have, or implement it ourselves because it's open source. 5, 4. But before implementing such a feature, it is important to always write an email to the developer mailing list, ask them what they are currently working on, what if they have any input and ideas how to do it, and if you are not doing a double work for someone. So BE, we will definitely need that connected to the FPGA. So let's just do that here. Yeah, this will be fun to figure out what the pinout should be of these pins when we connect that. So TXE, TXF, we definitely need those. We need the write, read, and output enable. So we will probably get away with 2 of these banks being for our data pipe. Yes, yeah, gummy bears are what makes things happen in the world. Yeah. Yeah, and you're wrong. I think the interface is very good. It's like Eagle is worse. It's only a different interface, that's all. And yes, I used Eagle long enough to know. It took me, what, 3 days to learn using KiCad, and I use it since, what, 3 years now? So it's more an excuse to not use it, that it is unintuitive. It's not bad. As every CAD software, and Chris would agree, every CAD software has its quirks. And KiCad has plenty of quirks. But Eagle has tons of quirks of its own. And not having keyboard shortcuts that are somewhat standard and intuitive in Eagle, if that is not unintuitive, then come on. Yeah, and I'm using KiCad when I'm doing something. When I have to get stuff done, I use KiCad. Because Allegro is also complicated moloch of software. That is, you have to learn and get a PhD for. Okay, so write, read, oh, output enable, we need that too. Yeah, so before I switched to using KiCad from Eagle, I was considering that KiCad will not be like good enough and have enough features. So I started looking into I think, yeah, was it Allegro or was it Orcat? I think it was yeah, I think it was Allegro, because I used the really old one. What is it? 91, whatever. And so that was the genuine option. And a friend of mine said, just try using KiCad, the nightly builds. Like, it was what, 3 years ago, before the 4.0 release. I was like, well, okay, I will give it, yeah, Altium, that's what I meant. Yeah, so I gave it a shot, and I was like, well, it can do things, it has features, but then I started using KiCad, and it's like, it's plenty capable, it's easy to use, it installs on all the OSs that I want to use. I don't have to use Windows, Jesus. And so yeah, that was a pretty intuitive choice, because KiCad, after the 4.0 release, really got things right, and it's only moving forward and only getting better. So yeah, I can complain as much as I want about the things that are not perfect about it, but it's definitely good enough for anything I need it for. And I don't have to pay a like crazy license fee to some corporation that would never listen to any bug report from me. So why should I give them any money if KiCad does it? So that's my view on this. All right, yeah, we have all this stuff connected. See, reset. Now we have to I have to check if I need to connect the reset and wake up pins to anything. Yeah, and we need to start connecting our front end. But before we do that, we can do, yeah, non-connect, they can be. Yeah, sure, go ahead. If that solves your problems, it's like, it's your choose your own poison. If fritzing is solving your issues, use it. But if you're trying to compare KiCad to fritzing, then again, seriously, dude. Yeah, thank God. All right. We will need those here. Oh, actually, I'm wrong. Actually, the bank 3 and bank 2 will be our interface, like front-end facing stuff. And the question was, oh, this will start becoming interesting here, because this is something I didn't think about yet too much. We want to be able to have enough pins on the front end for a decent logic analyzer functionality, as well as the trace interface. You find, yeah, okay, you find it counterintuitive. How long and how much did you use it? Did you spend an afternoon on it and decided that it is counterintuitive? Did you make a complete like board design with it and still found it counterintuitive and you couldn't use it? Yeah. There you go, Dr. Toon, you have the solution. Why are we using any of this stuff if we can just do some drafting? Fran would agree, probably. Oh, well, then I'm sorry that it doesn't, yeah, to each their own, to be honest. If it doesn't work for you, that's fine. The question is also which version you are using and you were forced to use. And yeah, usually you also hate software more that you are forced to use. It's against your will. So yeah, I can understand that part. Yeah, so this will be the front end. Also, what we might use the IOs for is the SRAM stuff. So this will be interesting. We might need to use something of this bank if we decide to connect the SRAM stuff. But the front end for the logic analyzer should be at least 16-bit, that's for sure. And then we want, just like with the FX2, we want clock trigger. So clock output, input maybe, and trigger. So that's our requirements. So we will have 18 pins definitely coming out of the FPGA. Okay, and we need still the power connections. So how do we do that the best way? Because the PLL needs a separate supply voltage and it needs 2.5 volts for the PLL. So we will definitely need a second voltage regulator. So let's do that. Copy block. There we go. Okay, we have power and we have 2.8, 2.5. Oh, what am I doing? Of course. .5. So I'm not sure. Oh, yeah, because I was trying to think why I was considering using a switching regulator for 3.3 volts, but this was still in the context of the USB-C connector. That was still the time where I was looking at some of the dongles, and the dongle had a switching regulator in there, and I was like, maybe I should use it. Yeah, but it's still more parts, more complexity. And depending on how much power this whole thing will pull, we can still decide to replace the linear regulator with just a buck, or like a step down. Okay, so let's see. We need the SPI voltage, and the SPI VCC will be 3.3 volts for now. And as I mentioned to Dr. Tune, we will look at the requirements of the chips a little bit later when, come on, copy it, there we go, to make sure if we have an additional power rail, and if we want to go down in the voltages and basically have 3 power rails, maybe we can just use the 2.5 volts for IO2, and we only use the 3.3 volts regulator for where we actually need it. So that is an idea. Then on the front end here, the VCC IO, we might make it choosable and switchable. So that because all the banks have their all separate VCC IO, which might be useful to be able to switch reference voltages for the front end. as long as we don't use any buffering between the FPGA and the actual front end. We will also add a bunch of protection hardware, like diodes. CDON. So CDON will probably be just connected to an LED, unless we connect it to the GPIO and read it, so that we know that the FPGA is ready and in a good state. That might actually be a good idea, to have the CDON connected to the GPIO and be able to read it out. Yeah, I think I do like that. Because on the evaluation board, it also has an LED on it. If I can find it. Don't even know where I have it open. There's a lot of TDI stuff. Yeah. Oh. The chat broke. Let's see. There we go. Should be better. You are laughing at Nexus, but as far as I know, Fran is still using AutoCAD on Windows 98 or something, because it just works and gets the job done, and she's familiar with it. So using old software, yeah, exactly. Now I remember, it's Protel 95, for example. A lot of people are still using Protel because they say it's not, they didn't break it yet. So Protel 95 is very much alive and used a lot. Like the UAV, some of the UAV autopilots that I'm dealing with, they are from universities and they are using Protel to design those. Yeah, the power stuff we can just have here. And flip the ground so that it looks nice, and then have it connected to the bottom. Or maybe move it like this. So that, yeah, I don't know where it will end up though, so we will see. This is ground. Oh, I copied that. There we go. Yeah, well, quality software is relative. It's like some people would say that Altium is, they broke it, so Protel is much better. Or are you talking about the 3D CAD shareware software? That's possible that it is very different. But yeah, just like 3D Studio Max for DOS, it was also very different than the current newer versions. And some people still like using the older versions because they're familiar with it. The shortcuts are in muscle memory and stuff like that. And they don't need the fancy new features for what they are doing. So yeah, just like people using pads also seems to be a good software for some people. I didn't even try it, so I don't know, but it looks very DOS-like. Yeah. Okay, C done. The reset is definitely, we know that. Copy. We might need some pull-ups and pull-downs around here, because I'm not sure about this. The SDO is, we don't need that. So the nice thing is it is hardware SPI, so if we had an external SPI device, we could use it as an output and have a hard IP block for this, but I don't think we need it at the moment. Yeah, and chip select. The chip select for the SPI, I don't think we need it, because this is passive, because we are pushing the data into the FPGA. It is not doing its own thing. But don't quote me on that. I have to still read in more detail the protocol for uploading a bit stream. And the SDO is probably like this. So for now, let's do this. We can remove this to no connect. And then C done, is that right? Let's do it this way so that it matches. Come on, C done. And we can copy this. Yeah, I'm pretty sure we need some pull-ups and stuff in here. VCC PLL. I have to check that one too. There's VCC. Yeah. Yeah, I definitely have to check. Okay, now I'm getting lost here. And the non-connect stuff, we can just leave non-connect, and we have to make those nice and NC pins. Ah, there we go. There we go. Very nice. Yeah. So, as I said, we were planning to run for about an hour, and I think the time is up. We got a bunch done. We connected the data pins. We can eventually also, for good measure, add a nice blue line and connect this stuff together like this maybe, and then have inputs and outputs like this, and then have bus, what is it, bus inputs place by a wire bus entry, and there are bus to bus entry. So how does this look? Ooh, fancy. So this is how it would be. Interesting. So we would have it connected like that. And yeah, we could. This is really just a line. Interesting. Oh well. But basically that's what it is. We have the data bus connected over here to the FPGA, so we are getting the FTDI connected. We also replaced the USB connector. We connected the differential lines, and we connected a little bit more power. The configuration pins seem to be connected. We need to, and I will make a note, check config circuit. So we will check that, and I have to probably add some pull-ups and pull-downs. Then another thing is check power rails, as Dr. Tune said. Basically bank speed versus voltage. And as far as I know, we should be fine with 3.3 volts in this setup, but definitely needs some checking. All right. Anyway, so that's it for today. This week, I don't think I will be streaming more this week because on Wednesday I'm already driving up to Portland. There is B-Sides PDX that I invite everyone who is in the area to join. Just search for B-Sides PDX. It will be a very cool conference with a lot of interesting people. Check out their schedule, and I will continue working on this, probably off stream, try to record the process for the edited video. But as you see, there is mostly just some legwork to be done, and I have to figure out the front end and stuff like that. Thank you for everyone who is on the chat and is giving good input and helps out with some of the more complicated design decisions and research necessary for this. And as always, if you have been, thank you for watching.